A very good morning and welcome back. Let us continue our journey in order to understand quantum mechanics. And the topic for today is Schrödinger's equation in time dependent form. But before going to the Schrödinger's equation, I would like to give some basic information to you on pen and paper. For example, I write an equation 4 plus 5 is equals to 9. Then this type of an equation actually represents what is called as an operation. Something has happened between 4 and 5 that we are getting an answer 9. Okay, so we had a system, we give 4 as input, 5 as input, and we are getting 9 as output. So there is some function, we don't know what this is. Similarly, we can have another operation in which when I give 4 and 5, some function, I don't know what that is, I can get answer 20. Okay, so when I say that this is an operation, any operation has two parts, has two different meaningful inputs. One is 4 and 5. मतलब एक हुए 4 और 5. 4 and 5 are called operands. Okay. 9 is also operand. Then we have another different looking symbols also, plus and equals. These are called mathematical operators. Plus and equals to. So when plus operates on 4 and 5 and then equals to operates on this, you get an answer equals to 9. Okay. This is a general notation of operand, operator, operation. And when you represent any operation in terms of numbers, symbols, you call that as an expression. This is very rudimentary form, बहुत basic level की understanding. Similarly, we can have different operators. ये जो operator है 4 plus 5 are called binary operators, क्योंकि प्लस को ऑपरेट करने के लिए कम से कम दो चीजें, दो अलग अलग चीजें या दो सिमिलर नंबर्स होने चाहिए थे. That's why binary operator. Whereas equals to may and may not be binary. I can write 9 equals to 9, 5 equals to 5. I can write like this. So this equals to sign may not be binary operator. It can be unary operator also. कि एक equals to के बराबर आपने एक और number लिख दिया. That's it. Fine. Or when you write x is equals to 9 or y is equals to 5, something like this. Unary operator. Similarly, in Newton's calculus also, you have some operators. For example, you take d by dx. When I'm saying operator, d by dx is certain type of operator which will operate on an operand given by 2x square, let's say. So when you will operate d by dx on 2x square, means you would take derivative of 2x square with respect to x, you will get 4x. Okay. Similarly, there is another operator, integral, from 0 to infinity, x upon x factorial dx, give you some answer, let's say. Okay. An operator operating on this operand. अब यहाँ इसको ऐसे लिख सकते हैं, from 0 to infinity dx which operates on something. ये जो ब्रैकेट के अंदर मैंने डैश लगा दिया, इसकी जगह कुछ भी रख दीजिए, you will get answer. For example, if I put x, you know the answer is going to be infinity. Got it? So this is the small notation of operand, operator, operation. और जब हम इसको किसी इक्वेशन के फॉर्म में मैथमेटिकल टर्म्स और सिंबल्स को यूज करके रिप्रेजेंट करेंगे, वो कहलाता है ऑपरेशन. हमने ये क्यों पढ़ा? You will get to know and you will see its utility in our lecture today. So we were at wave equation, and we in the last semester itself have done that the wave equation is given by a double derivative equation like this, del square y by del x square 1 upon v square del square y by del t square, where the solutions of this y are of this form: y is equals to a to the power minus I omega t minus x upon v. I'm not going to waste time on defining what omega is, what x is, what t is, what is v, that you all know. Another important thing is that this same solution can also be represented like a cos omega t minus x upon v minus ia sin omega t minus x upon v, just expanding this e to the power minus I theta term. You know Euler's identity. E to the power I theta is cos theta plus I sin theta. Using that, we can come over here. So now we will continue our journey with the solution y equals to a e to the power minus I omega t minus x upon v. What we have to do is we have to understand Schrödinger's equation in time-dependent form. Let's start with the wave equation. Here, deliberately, I have changed the symbol from y to psi because psi represents state of a system. So psi is equals to a e to the power minus I omega t minus x upon v. This is a simple wave equation. Now, on this wave equation, we will try to operate some calculus operations. Like very first thing is, we know that omega is given by 2 pi f and v is given by f lambda, where f is the frequency, omega is angular frequency. If you use omega is equals to 2 pi f and infuse value of omega in this equation, you will get this. You can pause the video in order. This will be the final equation. Now, I will use two different hypotheses coming from two different scientists. One is the Planck's hypothesis of quantization of energy. You know that energy is given by h times frequency, or in h cross you can represent it by 2 pi h cross times frequency. And then the de Broglie's hypothesis, which relates particle with momentum p having a wavelength lambda. Lambda is equals to h upon mv or h upon p, the de Broglie's wavelength hypothesis. Using these two terms, I will just take 2 pi f inside and multiply and divide my exponent term with h cross. And you see, when I have this 2 pi h cross f, this becomes equals to E. And over here, which is 2 pi h cross f upon v, it becomes P. So I get the equation a e to the power minus I by h cross et minus px. So from this wave equation, I have come to another different looking wave equation, which is having the terms of energy and momentum. Actually, this solution, the psi equals to a to the power minus I by h cross et minus px, is the state representation for a free particle. If you have a free particle which is not bounded by any other forces, it is totally free, having energy E, possessing momentum P, then the representation of that particular particle, or the wave representing that particular particle, is given by a e to the power minus I by h cross et minus px. So if somebody says that what is the wave equivalent or the wave equation for a free particle, you will have to answer this is it. Given energy and momentum, you can write its wave function. Now on this wave function, we have yet not come to the Schrödinger's equation. Now on this particular wave function, we will operate something. For example, the very first thing which I do is, I want that you should take the first derivative of psi with respect to x. Doing mathematics, you will get ip upon h cross a to the power that particular thing. Okay, just a matter of mathematics and calculus. Then if you again take derivative with respect to x of this particular term, that is del square psi by del x square, you will get ip by h cross and this whole term. Finally, you will get minus p square upon h square a to the power minus I by h cross et minus px. अब ये जो red में लिखा है, that is equals to psi. So it becomes as if I have a wave equation given by this particular form, and I take second derivative or second order derivative of psi with respect to x, it is as if I am just multiplying it with a constant number minus p square upon h cross square with psi. So del square upon del x square is same as इस साई के साथ केवल एक कांस्टेंट नंबर को मल्टीप्लाई कर दिया. This is the reason we can simply write that del square psi by del x square is nothing but equals to minus p square h square upon psi, minus p square upon h cross square into psi. Fine. Similarly, I can write after some rearrangements that minus of h cross square double derivative of psi with respect to x is similar as if I am multiplying p square with psi. That's it. इस तरीके के ऑपरेटर्स को आइगन वैल्यू ऑपरेटर्स बोलते हैं. आपने ऑपरेट किया, आपको वही का वही फंक्शन मल्टीप्लाइड विद समथिंग मिल गया. पॉइंट नंबर 1. ओके, नेक्स्ट इज you take that function again and take a derivative of it with respect to time. If you do that, you will get minus I by h cross e times the function again. और इसे rearrange करके you will get that as if I have minus h cross upon I del by del t of psi. If I take first derivative of psi with respect to time, it is as if I am multiplying energy with the wave function itself. Fine. So these are the two important equations, that if you take double derivative of this particular function with respect to x, it is as if I am multiplying p square upon h square into psi. And if I take first order derivative with respect to time, it is as if I am multiplying I by h cross the negative sign times e. Using these two functions, which is p square equals to minus h cross square del square psi by del x square, and obviously the energy equation. Now we'll come to our general notification and general notation of what energy is. So we simply represent that energy is equals to kinetic energy plus potential energy. Moving further, we get kinetic energy is because of the momentum or the velocity. जहाँ p लिखा है, it means mv, velocity अपने आप ही आ गई. इसमें आप mv रख के देखें तो you will get half mv square. Plus potential energy, as I always say, that potential energy is the energy because of position, because of arrangement. So position coordinate आ गया x with respect to x and time. एक particular समय, एक particular position पे कोई energy होगी. So total energy is given by p square upon 2m plus the potential energy. No worries. Now if you treat this as operator, okay, and multiply both sides with the wave function psi like this. So treating this as operator and operate on psi, जैसे हम del by del x को ऑपरेट करके किसी फंक्शन पे ऑपरेट करते हैं, ऑपरेटर मान के ऑपरेट करते हैं. Like that, I want that you should do e into psi, operate e on psi, operate p square upon 2m into psi and ux into psi. अब इन ऑपरेटर की वैल्यूज you can get from here. For example, if you want p square upon 2m into psi, you know what that means. P square upon 2m means I want to have minus h cross square upon 2m del square psi by del x square. तो ये दो चीजें यूज करके I can get the equation like this. So in this cloud, it says that operator operand operation expression. You recall in the starting what we were all doing. We discussed that we have a function and you are operating it on something. Okay, so recall that, you will not be confused. And finally, when you will infuse these two things like p square psi and h cross upon I del psi by del t, you will get the answer. तो p square upon 2m का मतलब हुआ minus h cross square upon 2m del square psi by del x square, और e का मतलब हुआ minus h cross upon I del psi by del t. तो टोटल e अगर हम लिखें तो it would become what? E को आपने देखे लास्ट टाइम कैसे लिखा था? Over here you can see it is minus h cross upon I del psi by del t. So e is this operating on psi. I should have written e psi over here. Okay, this is p psi and psi. The psi is missing over here. You remember that, okay? So this is e psi, this is p square upon 2m psi, and this is uxt of psi. This is your first order or one-dimensional Schrödinger's equation. If you want to write it in 3 dimensions, you can write like this. You have all the 3 position coordinates and that's it. Your potential energy depends on all the 3 position coordinates in time, and your kinetic energy, which is given by minus h cross square upon 2m del square psi by del x square del square psi by del y square del square psi by del z. So all the terms coming from all different position coordinates are there included inside. So this is not a derivation of Schrödinger's equation. What we have done is हमने ये जो ऑपरेटर ऑपरेंड ऑपरेशन एक्सप्रेशन की कहानी थी वहां से कुछ चीजें उठा ली एंड वी ट्राई टू हैव ह्यूरिस्टिकल. ह्यूरिस्टिक का मतलब होता है कि एक आइडिया लगाया कि हम एनर्जी को ऐसे लिख सकते हैं. दिस वाज डन बाय Schrödinger's. दैट्स व्हाई द नेम Schrödinger's equation. And Using this equation, Schrödinger could prove quantum mechanics being valid on all of the Newtonian mechanics system, like simple pendulum, harmonic oscillator, hydrogen atom. You have what? The tunneling examples, and many different approaches. So this all came in the year 1924 and so on. And because it was so powerful tool or so powerful mathematics that it became as if it is magic. तो जैसे फंडामेंटल F इज इक्वल्स टू एम से आप बहुत सारी चीज़ें कैलकुलेट कर लेते हैं न्यूटोनियन मैकेनिक्स, उसी तरीके से ये डिफरेंशियल इक्वेशन जो अभी आप अपनी स्क्रीन पर देख रहे हैं, इसे यूज़ करके क्वांटम मैकेनिक्स की कई सारी चीज़ें आप सॉल्व कर सकते हैं. 3 प्रॉब्लम्स आपके कोर्स में हैं दैट वी विल कवर. ओके, सो फर्स्ट टेक अ स्क्रीनशॉट, एक बार रिवाइज कर लीजिए इसे, मेक गुड नोट्स ऑफ इट, refer book, try to assimilate what has been taught. So Schrodinger's equation, time dependent form, क्योंकि यहाँ पे you see that we have the time dependent term coming in, that's why we say that time dependent form. Now we will come to a very similar topic, which is linearity and superposition. Although superposition we have already done when we were doing wave mechanics, but here you know that psi is something else. It is not just wave function, it is wave of probability, not wave of amplitude or something. Okay, so for example, if you are given that psi1 is a solution of Schrodinger's equation, psi2 is a solution of Schrodinger's equation, okay, then linearity says that psi is equals to some constant times psi1 plus some constant times psi2 should also be a solution of Schrodinger's equation. Okay, so this is what is from linearity, that if psi1 was a solution, it means अगर आप Schrodinger's equation solve कर रहे थे and you got a solution की psi1 इसमें fit बैठता है, psi1 डालने से whatever the form of psi1 is, you get this equation correct. Similarly, psi2, another different type of a function, is a solution of Schrodinger's equation, then a linear combination of these two will also be a solution. Okay, so the probability, we will come to the probability a bit later, don't worry about that. Okay, so let's come back. Probability P1, as I told you that probability is given by mod psi square in our lecture 1. So if your wave function was in state 1, let's say psi1, the probability associated with that particular state is P1 given by mod psi1 square, and the probability associated with another state psi2 is given by mod psi2 square. Okay, now we can have that one solution can also be from the linearity principle. If I take a and b equals to 1, I can write psi equals to psi1 plus psi2. So psi is also a solution which is sum of these two wave functions. Fine. The probability for P1 is psi1 square and probability P2 equals to psi2 square. Now the probability P, which is associated with the sum of psi1 and psi2, is mod psi square, is given by psi1 plus psi2 का whole square. Okay, so if you calculate P further, I can write that mod psi का मतलब होता है taking complex conjugate और फिर उसी नंबर से मल्टीप्लाई कर देना. तो psi1 plus psi का complex conjugate, psi1 plus psi2. इसका मतलब हुआ psi1 plus psi2 complex conjugate का मतलब हुआ psi1 star plus psi2 star. ये देखिए complex conjugate I have taken inside the bracket, where you know what complex conjugate means. And psi1 plus psi2 multiply करने के बाद I will get 4 different terms. एक है psi1 star psi1 which represents mod psi1 का square, that is P1. एक है psi2 star psi2 which is P2. Then some other interfering terms as well. Okay, so you can simply add the wave functions like psi1 plus psi2, but total probability निकालने के लिए you can not simply add P1 plus P2. It is P1 plus P2 plus something else. और ऐसा क्यों हुआ? क्योंकि linearity की principle follow करो ना. Linearity applies only on psi, not on probability. ठीक है? So wave functions can be added through superposition, probabilities cannot be. याद रखिएगा. ठीक है? It can be asked in quiz और qualitative analysis का एग्जाम अगर होता है आपका सीटीज में तो पूछ लिया जा सकता है. एक एग्जाम्पल, डायरेक्ट एग्जाम्पल, ये इंटरफेरेंस टर्म क्या रिप्रेजेंट करते हैं उसका है व्हेन यू परफॉर्म यंग्स डबल स्लिट एक्सपेरिमेंट विद इलेक्ट्रॉन्स. So you know that we consider electrons to be some sort of particles. And if you consider electrons to be particles, आपने you have a slit, ये मान लीजिए ये slit है. You are firing electron from electron gun, जैसे टंगस्टन फिलामेंट है उसमें से इलेक्ट्रॉन्स आते हैं, तो हमने इलेक्ट्रॉन फायर किए. एक बार में एक इलेक्ट्रॉन फायर किया लेट्स से, तो एक बार में एक इलेक्ट्रॉन हमें पता है कि या तो ये इस स्लिट से जा सकता है या इस स्लिट से जा सकता है, और यहाँ इस स्क्रीन पर कहीं कोई डॉट दिख जाएगा इफ इट इज फ्लोरेसेंट स्क्रीन. So what type of pattern do we expect? What type of pattern do we expect? Actually, what happens in this experiment is this. तो ये टाइम लैप्स इमेज है. यू कैन सी दैट जैसे जैसे वक्त बढ़ता जा रहा है यह एक पैटर्न इवॉल्व हो रहा है. एक बार में एक इलेक्ट्रॉन की वजह से ये सिंटिलेशंस या ये वाइट डॉट्स दिख रहे हैं, वन इलेक्ट्रॉन एट अ टाइम. यू सी. सो व्हेन नंबर ऑफ इलेक्ट्रॉन्स हैव इंक्रीज, बहुत ज्यादा इलेक्ट्रॉन्स आ गए, तो इट गिव्स एज इफ इट इज एन इंटरफेरेंस पैटर्न. हाँ, तो क्या आने वाले इलेक्ट्रॉन को पता है कि उसे कहाँ गिरना है, या पहले जो इलेक्ट्रॉन्स अपनी जगह गिरे थे उन्हें पता था कि उन्हें कहाँ गिरना है? व्हाट इज the principles behind it? What is governing this probability? What is governing this type of pattern? Classical electrons है. तो क्या बाद में जो इलेक्ट्रॉन्स आए उन्हें पता था कि हमें यहाँ पे एक पैटर्न बनाना है? What has happened? What is happening? If you go by time lapse image, we got something like this. एक बार में एक गिर रहा है इलेक्ट्रॉन, तो देखिए कहीं भी रैंडमली कुछ भी हो रहा है. B is also very random, कुछ दिखाई नहीं दे रहा, कोई पैटर्न नहीं है. C is almost random. बट D में देखें, जब आपने नंबर ऑफ इलेक्ट्रॉन्स इतने बढ़ा दिए, देयर इज अ पैटर्न. देखिए, ब्राइट डार्क ब्राइट डार्क ब्राइट डार्क ब्राइट डार्क. 1965 में दिस वाज लाइक अ रेवोल्यूशन. हु इज गवर्निंग द इंटरफेरेंस ऑफ इलेक्ट्रॉन्स? व्हाट इज द गॉड? हु इज द गॉड हु इज गवर्निंग दिस? क्या इलेक्ट्रॉन को पहले से पता है? देयर वर मेनी कॉन्सेप्ट्स लाइक पायलट वेव्स. देयर वर सम हिडन वेरिएबल्स कॉन्सेप्ट. वी डोंट हैव टू डाइव इनटू इट, बट अप्रिशिएट दैट क्लासिकल इलेक्ट्रॉन्स इंटरफियर. ठीक है, तो हुआ ये. इन द नेक्स्ट स्लाइड यू कैन गेट, this is all from previous slide. This is happening. You have electrons and you know that one electron can pass through one slit at a time. ऐसे नहीं हो सकता कि दोनों स्लिट से पास हो जाए. भाई इलेक्ट्रॉन है, कोई क्लाउड थोड़ी है. कुछ बोला, I said something. इलेक्ट्रॉन है, कोई क्लाउड थोड़ी है. Set this line apart. मैंने फ्यूचर बता दिया है. बट अभी फोकस कीजिए, वी आर कंसिडरिंग इलेक्ट्रॉन्स टू बी पार्टिकल्स. एंड पार्टिकल्स या तो स्लिट 1 से बाहर आएंगे, तो देखिए हमें ऐसे दिखेंगे. अगर मान लीजिए मैंने केवल स्लिट 1 को ओपन किया होता, स्लिट 2 क्लोज कर दी होती, तो यहाँ पे ऐसा पैटर्न मिलता. और अगर स्लिट 1 को क्लोज किया होता, स्लिट 2 ओपन करता, तो मुझे ऐसा पैटर्न मिलता. और इन दोनों का सम होता है ये, अगर दोनों खुल दी तो. बट आई वॉज गेटिंग दिस was explained by Schrödinger's phenomena कि आप actually consider कर रहे हैं only P1 plus P2, but it is P1 plus P2 plus something else. That is interference. This is the governing thing. Psi2 star Psi1, Psi1 star Psi2, interference term. Okay, so I hope you would appreciate this particular thing, and this we cover the linearity and superposition, and this also covers our topic for today, linearity and superposition. So expectation values and operators and then Schrödinger's equation in the steady state form we will take on from the next lecture. Thank you so much all of you.